Let's look at an example of a sampling distribution problem with p-hat, the sample proportion. When we're looking at the distribution of p-hat, remember it's a sampling distribution because it's a distribution of a sample statistic. I'm going to go through an example and talk about the specifics of it as we go through. So here it says in the U.S. 39% of the population has B positive blood type. Suppose we obtain a simple random sample of n equal 85. So there's 85 people that we've randomly selected, and we determine the sample proportion of those who have B positive blood type. So that's the situation that we're looking at. The first thing says describe the sampling distribution of p-hat. So p-hat is the symbol for the sample proportion, and the letter P is the symbol for the population proportion. Now when we're looking at the sampling distribution of the sample proportion and we want to describe it, if it asks you to describe it, you want to say the shape, the center, and the spread. Now the conditions with looking at the sample proportion, first of all, we need to kind of talk about our trials as being independent. And we can do that as long as our sample size n is less than or equal to 5% or 0.05 of the population. Now we're only taking 85, simply random sampled from the U.S. population. So definitely what we're sampling is less than 5% of the number of people in the population of the United States. So we're good there. Next up, with the distribution of p-hat, the distribution of p-hat, the sample proportion, will be normal if n times p times 1 minus p is greater than or equal to 10. There's our shape and how we check it. Just kind of to give you a little heads up, sometimes instead of writing 1 minus p, an author will write the letter Q. So just remember that Q is the same thing as 1 minus P. So we'll put it down here. Q is the same thing as 1 minus P. Okay, let's check that part. So N in our situation is 85. P, the proportion of the population, is 39% or 0.39. And then 1 subtract 0.39 is 0.61. And when we multiply those numbers together, we get about 20.22, which is greater than or equal to 10. So since that's bigger than 10, our shape is normal. What about the center? Well, the center of the p-hat distribution is going to be the same value as the population proportion. So center is the mean for this situation. So we're going to do mu, and we're going to subscript it with p-hat to say it's the center of the p-hat distribution. And that's the same thing as your population proportion p. In this problem, that's 0.39. So mu sub p-hat is 0.39. And then the last thing is the spread. The spread for a normal distribution, a good measure to use for that, is the standard deviation. And the standard deviation of the p-hats is the square root of p times q divided by n. So here in this problem, our standard deviation of our p-hat distribution is the square root of p is 0.39, q, remember, is 1 minus p, so that's 0.61, and our n is 85. And that comes out to be about 0.39. Oh, sorry. That comes out to be about 0.0529. So there's our describing the sampling distribution. The shape, the center, spread. Next up, what if they ask us about probability of a sample proportion? What is the probability that for a random sample of 85 Americans, the proportion with B positive blood type is less than 40%? Now, because we did this work with describing the distribution, and we saw that it's a normal distribution, and we know its mean, and we know its standard deviation, we can use the normal CDF in order to find this probability. So we'll do normal CDF of, and we can kind of think about the picture for this. It's a normal distribution. The center is 0.39, right? Okay, and we want less than 40%. Well, 0.4 is just a little bit to the right of 0.39 on their number line, and is less than that. So forever to the left of that, we'll draw a vertical bar at 0.40, and we'll kind of shade, and that's the probability we're looking for. So visually, we can see that we're shading more than half the graph. The whole area is 1, so I'm expecting a value that's more than 0.5 for my probability. Okay, so it's going to be from ever left is the low, so negative 1E99, comma, the high, which is 0.40, since I want less than 40%. The mean is the mean of the distribution, which we saw to be 0.39. And the standard deviation, you can actually key this square root in this last spot so that you get more accuracy from it. So we'll do the square root of 0.39 times 0.61 divide by 85. And when we go through and do that calculation, you get that that's about 0.575. So that is how we can also do our probabilities with those questions. So again, remember if it says describe a distribution of a sampling distribution of a sample statistic, shape, center, spread. And that information is useful. If you get that your shape is normal, then your probabilities can be done with the normal CDF. You just have to make sure you use the right mean and the correct standard deviation for that situation.